Let us look at addition operation of two sparse matrices. So already I have discussed how addition is done, but now let us write on the code a function for adding two sparse matrices. So for example, I have taken two sparse matrices S1 and S2, and this is their representation. That's a structure called sparse. We have already seen it. So that these are the objects of sparse structure, and already I have filled. This is 4 cross 5 matrix, 4 cross 5. 6 non-zero elements are there, that are 1, 2, 3, 4, 5, 6, 6 non-zero elements, and all the elements I have already filled here. Like this element 1 comma 3 is a 3, so 1 comma 3 is 3, or 4 comma 2 is a 6, so 4 comma 2 is 6. Similarly, I have filled this one also. Now let us write a function for adding these two sparse matrices and generating a third matrix, that is sum of two matrices. So already I have kept one pointer here. Now let us look at a function. Function name is add. It needs these two matrices. Now where these matrices are available, they are maybe present in some other function. So this function needs pointers to those two matrices. So I will write sparse. Actually, I should write structure sparse, but I am just writing sparse here. Pointer S1. So this is a pointer for first matrix. Then sparse pointer S2. This is the pointer for the second matrix. Now the function is taking two pointers, S1 and S2. Let us imagine that this pointer is pointing on this one, and this pointer is pointing on this matrix. So these are present somewhere inside, let us say, main function. Now it has to add those two. So inside the function, first of all, let us check whether these two matrices can be added or not. Whether they can be added or not, we can know it by comparing their dimensions. The number of rows, that is 4, 4 should be same, and number of columns 5, 5, means their dimensions must be same. So let us write on that first condition. So what I am checking here, if rows are not matching, columns are not matching, don't do anything. So first I wrote a code for checking this one. See, even I could have checked whether they are equal or this is also equal, then do all the operations. But the other way I have written, if they are not matching, stop, don't do anything. So first I have checked the false condition here, that is failure condition. If they are not same, then stop, don't do anything. Otherwise, they can be added. How to do that? So for adding, first of all, I should create a third object. So here already I have taken a pointer called sum. So for that I will create an object. So for that I should have a pointer inside this function, that is sparse pointer sum. So that is a pointer. So to that pointer I should create an object of sparse matrix having m, n, number of elements, and also a pointer e. I should have an array of some size. So what should be the size of this array? I should create the object, and also I should create an array of elements of some size. So first of all, let us create this object. So I should say sum assign new sparse object is created. Then here I should fill the dimensions. I can take the dimension from either S1 or I can take them from S2. So sum's number of rows m should be same as S1's number of rows, and in the same line I am continuing, sum's number of columns should be same as S1's number of columns. So this 4 and 5 I can copy that here, 4. Then how many number of elements? I don't know. Once I have finished adding, then I'll be knowing how many elements are there. So this I cannot fill up. Then this object I have to create. So what should be the size of this one? So unless I add, I cannot know what should be the size. But total maximum size I can have. So what is the maximum size? Number of elements here are 6 and here also 6. So total 12. So I will create an array of size 12. 12 may be more than the required size, but no problem. If you have some extra spaces that are unused spaces, no problem. So we will create an, assume that an array of size 12 is created. So I will mark few. Checking is completed. This is the way to check. Then creation of a new matrix, sparse matrix is created, and we have created in heap. Remember this, we have created in heap so that it can be used anywhere in the program. If anywhere in the program you have a pointer to this one, you can access this one. So I have created this in heap, then I have filled these values. So let us create this array. For that I have to say sums e assign new. So what is that? Array of elements. So new elements. So element is one structure, we have already seen it. And what should be the size? So the size should be the combined size of S1 and S2's non-zero elements. So let us say S1's num plus S2's num. So this array is created. So we have finished with the initial work. So I cannot write everything here. I have to remove this, right? So just have a look of this function. I have a pointer here. Then I am checking whether their dimensions are not matching. Then stop there itself, return 0. Otherwise, create an object of sparse matrix. Then create array of elements and set the dimensions 4 and 5. So this much work is over. Now, further, I have to add them. So for that, I will remove this and write down the code for addition. Now let us write down the code for adding them. So for adding these matrices, we need index pointers I at the starting of this, j at the starting of this, and k. So I, j, k, all of them should be 0. Then let us see the procedure. See, first check the row numbers. If row numbers, among these row numbers, if S1's row number is smaller, then copy this one there. If S2's row number is smaller, then copy that one. So whoever's row number is smaller, copy that one. So first I'll check row numbers. See, if E of I dot row number, that is I. If you remember, these are I's and J's and these are X. So if this is less than S2 cap E of I, if row number of this one is smaller than that row number, then copy this element, that is this element, in K. So sum of E of K plus plus assign with this element. So all these three things can be copied directly. S1's E of I plus plus. So if this is small, copy this one. But in our example, they are equal. So if it is small, copy that one. Else, if S1's EI dot I is greater than S2's EJI, means if that one's row number is smaller, then copy that row number here. So sum of E of K plus plus is assigned with S2's E of J plus plus. So if first one is small, copy that one. Second one is small, copy that one. If both are equal, then what? Check column. So this comes as else part. Else. Now check column numbers. If this one's column is small, copy that one. If that one's column is small, copy that one. Otherwise, add them. So I have to continue the logic here. If S1's E of I dot j is smaller than S2's E of j's column, then copy this element first. So I will continue in the same line. So copy in sum of E of K plus plus, copy S1's E of I plus plus. Otherwise, if S1's E of j is greater than S2's E j of j, means this is greater than that one. Columns we are checking. See, these are columns. J are columns. Then copy this element there. So sum of E of k plus plus assigned with S2's E of j plus plus. So we have finished with the row is small or row is greater, column is small, else column is greater, otherwise both are equal. So this is in final else. We have to add these two and store the result there. So final else, I'll simply write on the code here itself. So sum of E of k plus plus is assigned with S1's E of. So for copying, I have to copy three things: row number, column number, and the sum of the elements. So for row number, column number, simply I will copy the values from S1, say S1 of I plus plus. So actually, I have simply copied S1, this element, to sum, but I should add them. So I should add the value from this S2, simply add the value. So I need one more statement. So after this, I should say sum of E, now say k plus plus, in this x value, I should add the value from S2. So S2's E of j plus plus dot x value. That's it. Then this procedure should be repeated. So this has to be continued while I is less than number of elements of this one, that is num, S1's num, S1's num, and j should be less than S2's num. So this loop will be comparing and copying the elements. I will just trace this code and show you a little bit. So let us trace the code. See, first row numbers are compared. Row numbers are same. So it will, so this is not smaller, this is not greater, so it will come to this else part. Then column numbers is checked. First one's column number is smaller. So this will be true at this point, this will be true. That is, row numbers of these two are same, but the column number is smaller. So 1, 3, 3 will be copied here. So 1, 3 and 3 is copied here. K is moved ahead, I is moved ahead. Now in this case, row numbers are checked. This is 2, this is 1. So this is false. So this will be true. So this roll number is smaller. So 152 is copied. So 152 is copied. Then j is incremented and k is incremented. So this was true in this case. So the element from S2 is copied. Let us continue. Now row numbers are equal, 2 and 2, but the column number is 1 and column number is 2. So again this condition will be true. Column numbers, this condition will be true. So 2, 1, 4 is copied. So 2, 1, 4 is copied. K is incremented as well as I is incremented. Now this time 2 and 2 row numbers are same. But column number, this is greater, this is smaller. So row numbers are same means it will go into else part. But column number, this is greater than that one. So this will enter into this else part. See, this column number is greater than the column number of S1. S1's column number is greater than S2's column number. So S2 will be copied. This S2 will be copied. So 2, 2, 5 is copied. 2, 2, 5 is copied and K is incremented. J is incremented. Now this time row number 2, 2 are same. So it will enter into else part. Then here column number 5, 5 are same. Then it will enter into this part, this else part. So it will copy the element from this one, that is 2, 5, 7. So 2, 5, 7. As I have copied S1's element, then I is incremented. It will move to next. But that value should also be added. So here I am adding in X, the value of this one, X is added. So it should be added plus a sign. So this value is added. 6 is added to this one. So this becomes 13 and K is incremented as well as J is incremented. So that's all. I have shown you all the cases. One time it was true here and it was true here also. And I have also shown you all three cases. Now similarly it will continue and it will add all the elements. So this type of code I will be writing in my program for adding two sparse matrices. Then at the end, whatever the value of k will be, so that will be set as the k value, number of non-zero elements. So that's all about addition of sparse matrices. We'll look at the program.